report. This is our static analysis report. The key design requirements that we wanted to look at were we wanted a model that was easily adjustable, had a design that wasn't complex, and then that would also be able to support the required 2,000 pounds and work for at least 10,000 cycles. And so we chose to just use a classic scissor jack design and design the frame out of stock parts, same stock parts with different sizes. And then with that design, we made sure to at least have a safety factor of 2.
The key failure points that we identified was buckling of the screw rod and tear out of the aluminum pin joints. The length that we decided to do a lot of our testing for these failures was 16-inch length for that rod, which would be about the maximum stress in all the members.
So this plot here shows the safety factors we calculated dependent on the length of the crossbar. And at very short lengths, our safety factor was very, very high, but as the crossbar lengthened out, it dropped to about just under 10. But even at these longer lengths of the crossbar, the safety factor was still well within the requirements that we had set for our model. And the same can be said for the frame as well. So this is the plot for the top frame. Our aluminum frames have a slightly different cross-section from one another between the top and the bottom. But you can see again that we have a high safety factor with short crossbar lengths, and as the crossbar length is increased, that increases the force and brings the safety factor down, but it is still well above what we deemed necessary for our model. And again, in the second one, follows a very similar trend to the first frame member.
And then each of these failure modes were analyzed in finite element analysis. And here's the buckling of the crossbar. And so the end conditions consist of both ends being able to rotate, we're free to rotate about the Z axis, and that on one end, the displacement is 0, and then on the other end, it can move in the X direction. And so it was found that the point at which it buckles was approximately when there was a force of 3,415 pounds, and that is at a length of 16 inches. And then the tear out was analyzed by having a bearing load where the holes are seen. And this was analyzed at using a yield strength of 16,000 PSI. And so once the max shear around these parts reached about the yield strength is where we determined that tear out would occur. And so this occurred at about 2,100 pounds.
And as you can see in this table here, the safety factor for buckling and tear out based on yield in the center crossbar and in the members matched pretty closely to those that we found using the computer model that we created. And it was also very close to the values found in the FEA, so we felt very comfortable with the results that we found.